Hello all. Today we are going to discuss about the attacks which are launched on Cipher. In the previous video, we have encrypted and decrypted the plain text and the corresponding ciphertext. That is, the plain text student is encrypted to VWXGHQW using the Caesar cipher algorithm. Now, we can decrypt this particular ciphertext back to the plain text only when the key is known. What if the key is not known, but the attacker will able to decrypt this particular ciphertext? Yes, there are possible cases. Those possible cases are known as attacks. So there are two types of attacks that can be launched on Caesar cipher. The first attack is called as brute force attack. Since we know that brute force is nothing but trying out all the possible keys. So in normal problem solving, we'd be telling that brute force is like trying out all possible solutions. The same way, brute force is all about trying out all possible keys. Which means, in English, the key range is from 0 to 25 and the attacker will be trying all the keys from 0 to 25. In this case, we have used k is equal to 3. Which means when the attacker uses 3 as the key, he'll be able to decrypt this to student. The second one is frequency analysis attack. This is quite strange. This is not an usual type of attack because in frequency analysis attack, when the given ciphertext is seen by the attacker, he'll be trying out to list what are the characters that have repeatedly present in this particular ciphertext. For example, in the ciphertext, the frequency of W is considered as the highest, which means W's occurrence is the most compared to other characters in the ciphertext. The same way in English, the frequency of E is the highest compared to all other characters, followed by T, followed by A, and so on. We know that when the ciphertext is given, the corresponding plain text is found using this particular formula where P is equal to C minus K mod M. In brute force, we'll be trying out all the possible keys, which means from 0 to 25 to get all the possible plain text. From that, we'll be selecting the meaningful text, which is the plain text. But in frequency analysis, this is quite different. At first, we'll be finding the key, only then we'll be finding the plain text, which means in frequency analysis, we'll be finding out the frequency of the particular given ciphertext. Here, we're going to find the frequency of W because W is repeated twice. So, K is equal to C minus P mod M. It is very simple that if we remember this one formula, C is equal to P plus K mod M. And from this, we can derive the formula for both decryption and finding the key in frequency analysis. So now let us have a quick example for both this brute force and frequency analysis for better understanding. Here is the example for brute force. Launch brute force attack on Caesar cipher if the ciphertext is ZOCDXN. So that we know the formula for decryption, that is P is equal to C minus K mod M. Now we are going to use all the keys from K is equal to 0 to 25. But using 0 is meaningless because when we try to use the key 0, we'll be getting the same answer. So we are going to try it from 1 to 25. Now let me try the key 1. So for key is equal to 1. What is the ciphertext? It is Z, O, C, D, X and N. Now it is better to use the list that we have already written, which has the alphabets and their corresponding numerical positions. So use that. And for Z, it is 25. For O, it is 14. For C, it is 2. For D, it is 3. For X, it is 23. And for N, it is 13. So now we have written C. And the key which I am going to use is 1. So the key is 1 here. Now we have to perform subtraction, right? So this becomes 24, 13, 1, 2, 22 and 12. Now I have to reduce it with respect to mod value. So the mod is 26 for English. So the mod value is 26. Now 24 mod 26. Guess it right? Yes, that is 24. This is 13, 1, 2, 22, 12. So since 24 is less than 26, the mod value, the remainder is 24. 13 mod 26 is 13 since 13 is less than 26. Similarly, we write the reminders for each and every positions. Now we have to assign the character for each and every numbers present here. So 24 in the list that we have written, 24 corresponds to the alphabet Y and 13 corresponds to the alphabet N, 1 corresponds to B, 2 corresponds to C, 22 corresponds to W and 12 corresponds to M. Does it make any sense? Y, N, B, C, W, M, who are going to encrypt this particular message? No, right? So this is how we have to think. So this is not a meaningful text, so key is not 1. And did you note something? I have used the key 1 and just look into the ciphertext and also have a look at this plain text. This is Z, this is Y, this is O, this is N, this is C, this is P, D, C, X, W, N, M. Do you find any similarities? Yes. The letters are shifted one position to the leftmost side, which means the previous character of Z is Y, the previous character of O is N, the previous character of C is B, the previous character of D is C, and so on. So what does it mean? In brute force, we are simply shifting the number of positions. So in case if I'm using K is equal to 23, then from Z I have to move 23 positions in order to find the correct plain text. This is how it works. Let's simply write down. I've just listed all the characters here. Now I have tried it up to K is equal to 20, but I didn't get any of the possible or meaningful characters. Now I am going to try it for K is equal to 21. Okay, for 21, given ciphertext is ZOCDXN. From Z, I am going to shift. For K is equal to 21, let's start from Z and let's start shifting. So it is like from Z, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So from Z, if I shift leftwards, I get the letter E. Okay, let's just write down E. Okay, next, what is the next letter? O. Okay, from O, if I shift 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. It is T. The same way for C, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That is H. And for D, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. It is I. And for X, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Yes, it is C. And then for N, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So this is the plain text. I got some meaningful plain text, that is ethics. So this ethics is actually encrypted as ZOCDXN, and I have used the key 21 to decrypt this particular ciphertext. So it is possible, even without knowing the exact key, the attacker would be able to decrypt the ciphertext using brute force attack. So Caesar cipher is vulnerable to brute force attack. So this is the example for brute force attack. Now we're going to see the example for frequency analysis attack. Launch frequency analysis attack on Caesar cipher if the ciphertext is KDI, KRR, KTIK. So now we need to use this, we need to perform frequency analysis attack to find the corresponding plain text. As I have already said what is frequency analysis attack, we are just going to find the highest frequency of the character present in the ciphertext and then the highest frequency of English, which means the character is E followed by T followed by A and so on. So for this we are going to use E alone. Now let's proceed with the formula to find the key. For frequency analysis, first we have to find the key, only then we have to proceed with finding the process of the plain text. For this, let us derive from this formula C is equal to K plus P mod M, and I need the value K. So K is equal to, I need K, this plain text goes this side, so C minus P mod M. This is the formula I am going to use in order to find the key. Okay, so this C is nothing but, this denotes the most frequent character present in the ciphertext, and this P denotes the most frequent character used in English. So this C is nothing but frequent letter present in the ciphertext, and P is the frequent letter used in English. Okay, in this case we are going to use the letter E, and here we have to check which letter is the most frequent. Here the K is present 1, 2, 3, 4. So the K is present 4 times. So K is the most frequent letter. And now I'm going to find the key using this formula. K is equal to, what is the ciphertext? The ciphertext is K here. And what is the plain text? It is E here, and then mod 26. Now what is the numerical equivalence of K and E? K corresponds to 10 and E corresponds to 4, and then mod 26. 10 minus 4 is 6. 6 mod 26 is 6, obviously, because 6 is less than 26. So we have found that the value of K is 6, which means I have to use the key 6 in order to decrypt this particular ciphertext. Now I am going to decrypt this particular ciphertext using this K. That is very simple. So how do we decrypt it? Using the formula P is equal to C minus K mod M. So what is C? C is nothing but K D I K R R K T I and K. Now just substitute the numerical equivalence for each and every character. So for K it is 10, for D it is 3, for I it is 8, for K it is 10 again, for R it is 17, for K it is 10, for T it is 19, for for I it is 8, and for K it is 10. So we are done with the part C. Now I have to subtract it with K, and we have found that the K value is 6. And this is C minus K. What is 10 minus 6? That is 4. What is 3 minus 6? That is minus 3. 8 minus 6 is 2. 10 minus 6 is 4. 17 minus 6 is 11. 17 minus 6 is 11. 10 minus 6 is 4. 19 minus 6 is 13. And 8 minus 6 is 2. And 10 minus 6 is 4. And now we'll be reducing it with mod. So mod 26, which is 4 mod 26, and so on. We should be very careful in dealing with this. 4 mod 26 is obviously 4. Minus 3 mod 26 is, we have learnt it already. For the numbers that we're dealing with negative, at first we have to write it down. So it is minus 3 mod 26. All we have to do is neglect this negative sign first and perform the modular operation for this. So 3 mod 26 is 3, obviously. Now just include this negative sign and add it with the mod value. This gives me 23. Simple. So 23 is the answer. And this is similarly to 411. Since all the values are less than the mod value, we replace as it is. Okay. Now we are gonna write the corresponding characters. 4 is equal to E, and 23 is X, 2 is C, this is E, this is L, E, and C, E. Which means this particular ciphertext is decrypted in order to get this particular plain text excellence. So we have launched frequency analysis attack to perform decryption without even knowing the keys, but with the help of knowing the frequency of characters present in the ciphertext as well as the frequency of characters in English. So this is all about frequency analysis attack. Thus we have seen brute force attack and frequency analysis attack in Caesar cipher.